You're listening to a Pop House Network podcast for developers by developers. Welcome to Java Pop House episode 90, Records. Hey everyone, my name is Freddie Gibe. I'm one of the co-hosts here at the Java Pop House. If this is the first time that you're tuning in, I'm I'm an author, work with Josh Juno and some other good folks. Speaker, I've been speaking at a conference across the US, Oracle Code 1, DevNexus, go to Chicago, and I also help run here the Seattle Java Users Group where I'm based. I'm also a principal engineer at Expedia Group, so if you have been booking flights, I'm sorry if you found a bug. That's probably me. So, and I'm here with my partner in crime, Bob.
Hey, Bob Paulin, independent consultant from Chicago, Apache Software Foundation member, Java champion, speaker, and CJUG, chairman of the board.
Nice. And today is an interesting experiment because this is, if you've been listening for a long while, you know that we usually tend to do this as an audio-only podcast, but this will be the first episode where we're going to try to accommodate video and see how that looks like. So if you want to check it out, you have to go to the Java Pop House website, and then we'll put both the audio and the video should be in there for you to enjoy. Before we dive in, I did wanted to thank our sponsors. Our sponsor here is Datadog. Today's show is sponsored by Datadog, a monitoring and analytics platform that integrates with over 400 technologies, including AWS services, Docker, and Kubernetes. Datadog's platforms brings together metric, traces, and logs in one place, so you can get full visibility into your environment and improve your application performance. With machine learning-based alerts, customizable dashboards, and distributed tracing, Datadog makes it easy to unify disparate data sources so you can troubleshoot faster. Start your free Datadog trial today. Listeners of this podcast will receive a free t-shirt once you install the agent and create one dashboard. Visit javapophouse.com/Datadog to get started. Again, the URL is javapophouse.com/Datadog to have it a go. And we thank them for sponsoring the podcast. They make sure that we can, keep recording, the mics on and hot and recording. And now we are going into the video side of things, it's going to be fun. We thank them, give them a try. The product is great. It's fun to actually see how all the metrics and measures come into the dashboard. All right, so this episode is fun because this is something we've sort of been waiting for, or at least I know that I've been waiting for a long while. Java 14 was released, and with that release, there came a bunch of goodies. The one that is the one that I am most excited about, I guess, or at least one of the things that I'm the most excited about is records. We've been hearing this for a long while. There has been Brian Getz has been always wanted to do records. There has been sort of before Java 14, there has been sort of the poor man's quote unquote records, using Lombok, which I use extensively. And what this is, I guess, is a way to address one of the bigger complaints that Java has, which is the Java is a very verbose language, right? Every time you create a plain old Java object, you have your getters, you have your setters, and other languages, even other JVM languages have been trying to sort of reduce sort of you're setting a field, you're getting a field, for example, I think Kotlin and Groovy are two that tend to minimize how that is being declared and how it's being consumed, where you just have to say look, this is a pojo, this is a field, make sure they're getters and setters, and then sort of forget about it. If you've been using Java, we have been talking about Lombok sometime before, where Lombok essentially is a preprocessor and annotator where it would just essentially parse your stuff, and when you have an annotation, it will sort of magically generate them behind the scenes for you, so you don't have to write getters and setters and stuff with the add data and add builder. But it's essentially, and like we said, it's a poor man's records, because what happens is that it's not a real like JVM supported thing. And so some things that happen is, for example, one of the biggest complaints that people get is that if you're breakpointing, you might be breakpointing on something that you never typed that is technically empty. Or if you happen to have more logic than the getters and setters, sometimes you are like breakpointing on a place that is completely different because the line numbers don't line up.
Yeah, and before we dive too far into the weeds, because you're already
I'm excited.
You're already
I was
this
ready
is
to
how
go.
it works. Let's just talk about. So I mean, you touched on kind of some of the background with records. I mean, as you said, this is a feature that exists in a number of other JVM languages. So Kotlin, absolutely. Groovy it doesn't have records, but again, it does have the low ceremony object classes. And records is, I don't know, maybe I view it a little bit differently. I'm not looking at it only as syntactic sugar. There's a part of me that looks at this structurally and says, this is Brian Getz on his journey to value types. And this is kind of a first step into saying, okay, we're going to define some data objects where the fields are immutable, right? Where equality is starting to be more managed for you. And certain things about the object were kind of taken away and limiting you with. As almost like a toe dip in the water as you know, how are people are going to use these immutable data structures. But I mean, obviously, as you said, it's not a new construct within the JVM. And, you mentioned Lombok. And when we get into the details of how all this works, under the covers, it's very much like Lombok in where there's code and bytecode being generated for you. Or managed for you, but through the JVM, where the compiler is taking these things and setting them up for you. So one place to start at. So I mean, what does a record look like in Java? So maybe I can share my screen and we can give our first attempt at what this looks like.
Yes.
So here's my Eclipse screen. And what I have right now, is this big enough? Is this legible to you, Freddie?
Yep, I can see it.
All right. Let me make it even a little bit bigger. So this is a preview release of Eclipse that has support for records on Java 14. So as you can see, if you look at it, just like a class, you have package, and I have package com.bobpaulin.record. So you mean semicolon. So you still have the same sort of start as you would to a normal Java class. The record I'm creating is a public record. Not all records have to be public, but the one I'm showing right now is. So you still have public records. So you still get all the privacy encapsulation that you normally get with your classes. But instead of class being the next word, it goes public record.
So that's a new, essentially, is a new token on the language. So
exactly. So they've changed some of the syntax of Java to accommodate this. And what's interesting is we're going to talk about syntactic changes, but then all of the things we're going to talk about how it works under the covers, it's going to be good old stuff that you should be maybe familiar with from other things that the JVM does for you. So after record, it's the name of my record, which I have right now is awesome. And then unlike a class, the record name is followed. It looks like a constructor, right? So it looks
like a signature, like a method signature, right?
Exactly. So it's got parenthesis, open parenthesis, and then inside there are your parameters. So I have int space num comma string space stuff, and then end parenthesis to say this is the end of the fields that are going to be a part of my record. Then inside of that, after that, I have a curly brace and then a closed curly brace. So right now my record doesn't have any methods in there. And, that may look very open and empty, but at the end of the day, because the record type is going to do some things for me, I may not need to put anything in there. So
No,
let's
this-
so
this
let's
is
talk
interesting.
about each of these pieces. So let's talk about the parameter. Why don't we start with, okay, so we've hit on a few differences between classes and records, just in
interfaces, yeah.
syntax, right?
Yep.
So the next piece is maybe going through and saying, okay, well, what is it that I can do with a record or what is it that I get from a record that I don't get for free with an object? Well, the first thing is you don't see getters and setters, right? So how does that exactly work? So if I were to go in, say and here I have just a main method. Let's actually see the instantiation of a, here, let me get rid of some fun stuff we'll get to later. So if we look at how I use my awesome record, it looks very much like a constructor of a class, right? So I have awesome space and the awesome, which is the name of the reference that we're gonna use,
The variable
equals,
that we have, yep.
and then I use new, just like I would for a class, awesome, and then I pass my fields directly into the constructor. So far, looks just like a class, right?
Yep. Yep.
However, one thing I can do with the awesome object is I can type the awesome and then dot. And let's say if my first field name was num, I could do num, open parenthesis, close parenthesis, and without typing anything in the definition of the record, I have an accessor. Right? So that will return to me what I set in the record's constructor, so to speak, for the field num. And I didn't, again, this is all code generation behind the scenes. It's not get num, it's just the name of the field. So if I were to go to the object again, and that, of course, return type is typed to whatever type that field is. And I can use other classes and things in it. If I were to use stuff, I also have a string that will return from stuff. And I can set objects equal to that. I can do whatever I would do with a normal accessor method. Now, one thing you're not seeing is there's no way for me to call set num or set stuff, which kind of brings us to one of the first kind of structural differences between records and classes is records are meant to be immutable, right?
All right. So, and that is interesting because that, they are inherently, their inherent advantage for having immutable objects, right? Essentially, it mostly involves around thread safety, right? Like safe publication. Once the object is constructed, it means that you can share this among threads, and you never have to worry about things changing values, underneath you because they're essentially immutable. So records are essentially enforcing immutability for you, which is not a bad practice. For most of the time, you do want immutable records.
Yeah, and again, it's kind of giving you some of those protections and things for free. So records, again, under the hood are all final classes too. So you can't extend a record. There's certain things you just can't do with them. So they're limited in that sense. Just like you would, if you put final on a class, it's not really meant to be extended. You're supposed to build them with composition. So if you're going to try to build records of records, you're not going to use inheritance to do it. You're going to make the record maybe a field of another record so that you have, all of these things kind of built out and you can have one large immutable object at the end of the day. So let's talk about some of the other things. So you saw that, hey, I get all of these accessor methods for free. I didn't have to write any code, so it's much shorter than a normal class. What's some other things that I might get for free? So what if I wanted to print this? So if I do system out print line, and I point in the awesome, which is the name of my object.
Because it's
and I
awesome.
run this program.
You life coding.
Yes. Oops, I still have my my debugger on there. Let's take that off for now.
We already made the demo gods angry.
Yeah, we already made him mad. Okay. But here you see on my screen, normally with a class, you print a class without any definition.
Overrides on the
You're
two
just going
strings,
to
yeah.
get the number, right? You're going to get the hash of the class, right?
Yes.
Here, I actually get awesome, which is the type, bracket, and then num equals 1, comma, space stuff equals test, end bracket. So they've already overridden toString for me to give me a readable printout of my object without having to do any work.
Nice. Because I always find it like it's so annoying when you forget about that and you're in the middle of debugging something, and then realize that you never had your toString implemented. So
right, yeah, or you're trying to debug something with, you're just gonna I'll just print it out. What's the worst that could happen? You just get a number or something. It's like, well, what am I supposed to do with this? I can tell if it's the same object or not, but what's in it? I have to do a breakpoint for that, or I had to implement logging properly the first time. Who does that?
Oh gosh, yeah. No, the worst one is when it's in a log file somewhere and there's no way that you can reproduce the error, and that's when you hit yourself in the face. It's like, Lord, if I only had what the object contained.
Exactly. All right, so let's get on. So print line, we've got accessor methods for free. Let's talk about some of the other things you get. So let's say, what if I was going to create another one? So awesome, I'll say another awesome.
Yeah.
And then equals new awesome. And then let's use the same parameters just to make it interesting to start with. So 1, comma, quote, double quote, test, end double quote, and then parentheses, semicolon. So now I have an object that has the exact same parameters that I had in the awesome object. So what if I was going to print, so system out, print line, whether the awesome equals another awesome. So, what would happen in a regular Java class? What would I get here?
If you never overrode the equals or hash codes, they're going to be just have reference equals, which they're not.
So it's going to be, it should return false, right, for a regular Java object. But if I run this, it actually returns true. And the reason this is again, by using the record type, they have overridden equals in a way that based on all of the fields, they're going to do the evaluation for you to say, hey, every single field that you put in, those fields evaluated all equals true. So now this record is actually equal to this other record without doing any work. So if you have records composed of records and it's turtles all the way down, you could potentially do deep equals on a very complex object.
And it's interesting because then that makes sense, because you're getting this, and it is one of the things that Brian Guest was saying, like when you essentially let go of a degree of freedom, you start getting things for free. Like in this particular case, like for example, the one thing that you're letting go is, and it makes perfect sense, is you cannot extend awesome, right? You cannot extend it. There's no ability for you to actually use like inheritance on it. And then that makes it, because you're giving up sort of like that particular constraint, it's super easy then for giving you an equals implementation. Because like one of the big things that breaks equals is sort of like class hierarchies, and then
Right.
And that's why, there's ways to sort of quote unquote generate some equals, which is like the way you think it. But once you have class hierarchies, that becomes super hard because if class superset equals another, class that it's inheriting from, where the base components are the same, but the superset or the extended class has more properties, right? So these are weird questions that are introduced because of inheritance. But if you essentially say, no, you can't inherit from records, then you know what? Because you're giving up some of these sort of degrees of freedom, it's super easy for us to implement what we consider a very, very natural equals method, which is take all the particular properties and see that they're equal on their own, right? So
exactly. Yeah.
That is so cool.
Yeah. So, I mean, you start getting this for free. And, when you start talking about, how it works, say under the covers, one of the things that I was looking at before, started into this episode and getting ready is this Records Come to Java by Ben Evans. So he's he's one of the guys. What was the company? It just got bought. J Clarity.
Yeah, J Clarity.
So I think he's at New Relic now. But he's written this up on Records Coming to Java and kind of goes into the sort of the things going under the covers. And in talking about it, he also talks a little bit about, okay, well, what do I have to do to get this to work? So in my demos, I have all of it built out a bit so that, you don't see any of the enabling of the preview features in my project. And we'll get to that in just a minute. But he also shows some of the boilerplate that gets generated for you. So this is a Java P that he's run against a class that he's put together. So what you see is this class is not unlike mine, where it only has definitions in that quote unquote constructor for the record. But when you Java P the class, you see the toString method exists, and it's all objects have it, but at the class level, and you see all the accessor methods being generated. You see your equals being overridden here, just like you would if you were trying to, build all this out yourself. But all this gets generated. So, Freddie, you were talking about Lombok. This is sort of what Lombok is doing.
It's interesting.
Under the covers at build time.
Now, to walk a little bit on what Ben Evans was doing. So Java P, for those who don't know, is essentially almost like a decompiler. Where not quite a decompiler, but what it's trying to do is essentially we'll look at the bytecode definition. So this works essentially on dot classes. So once you actually go through the build process, you generate on your project, you generate a bunch of dot class files, and you can actually just type in Java P space and the name of your class file. And what it's going to do is going to essentially give you a map of what the Java, the bytecode that was produced and how does that map to actual quote unquote Java instructions. Most of them map neatly. Some of them invoke dynamic. There's no quite. It's a bytecode. How do you call that? A bytecode instruction, but it doesn't have a particular Java language equivalent. So those are not going to be they're shown differently here. But when you look at it, it decompiled it, and it really just looks like it decided to do what you expected to type in if you were going to type a project for yourself. So
yep. So you get all that generated, and then in order to get this functionality working, Java 14 only has this as a preview feature, so it's not something that you get turned on by default. So that's probably also another really important thing, because everything else we've covered on the show has been something that's been in the JDK and you could use and was ready to go. This is something, it's just for playing around with. You're not going to probably ship production code with this yet. It's really out there for experimentation and for the OpenJDK folks to get feedback on how these are being used so that they can put together a final release records later.
Which means that this in theory can change.
Exactly.
Yeah.
So the implementation, the underlying implementation, perhaps some of the features could potentially change. So in order to experiment with it, you have to do a couple of things with your IDE to get it ready. So the very first thing that I did, so if we bounce back to Eclipse here, is you have to enable. So first of all, you have to be on JDK 14. So I downloaded JDK 14 from Azul Zulu, which is kind of my go-to. And then within Eclipse, if you look at the project properties on the Java build path, oops, not Java build path. Actually, it's in the compiler. You'll see I've set my source level compliance to 14 because you're compiling against the 14 version of the source compiler. And then Eclipse has it where you can just click on enabling preview features in Java 14. And then if you're using the Eclipse IDE in order to run your code like I have been, it automatically sets those flags on the compile and the run when you're going through it. Now, let's say, you're not an Eclipse user, but you're using Maven. Similarly, you can use a Maven POM to set the Java version property to 14 so that it gets picked up by the compiler plugin. And then if we go down within the compiler plugin, I can set release 14. And then under compiler args, which is under the configuration setting, you can set an arg element -- enable - preview. And that, when it compiles, will create the jar file with enable preview on. Likewise, if you're running tests, you need a similar configuration under the Surefire plugin. So this one, I'm actually missing the arg. So let's write that in. And then that would enable preview for your unit tests to run as well. So kind of an important thing. All the IDEs kind of have a little bit of a different setting. The other one I looked at was NetBeans. NetBeans has it where you have to basically run the IDE on 14. Eclipse still works if you run it on Java 8. But with NetBeans, if you run it on 18 and disable the NetBeans compiler library, you can enable the enable preview feature within NetBeans as well.
I see.
I'm sure IntelliJ also has a setting, they're always ahead of the game as well, where you can start enabling these and start playing around with them. And, the nice thing is, the IDE support so far has been keeping up with the Java release cycle. So that's been kind of exciting to see. Eclipse, I've got this little R. It's kind of hard to see on the screen, but I got a little R next to my awesome record to indicate that it's a record.
Nice.
Not a class. So you do get a little bit of IDE support right now. And that's been nice. But this only works on 14. If you try to compile this anywhere before that, it will break your code. So this may end up being another one of those things with those multi-release jars. I know you and I talked about those in a prior talk at Java 1 last year. But this is definitely not a non-backwards compatible change. So if you're going to be using this and really experimenting with it, using like your build plugin, like a Gradle or a Maven POM to enable this feature, so that it doesn't matter which IDE you're using, it comes in. That is one of the things that you'll have to look at.
Got it.
All right. So that's enabling, and that goes for any of it, because there's also switch statements in 14. There's a couple other preview features. They started using these in 9, I believe, the whole enable preview thing. So, each release kind of comes with its own little set of goodies under the enable preview guys.
No, yeah, and that is, I think that once they start adopting the 6 months cadence, they are doing it so they. Before it used to be extremely hard to get quote unquote a preview of features, right? Like you got what you got on Java 6, then you get what you got on Java 7. and then essentially you have to get the builds out, and then if you wanted to preview something, you have to get the builds before the release was done. This is a way that or dedicated developers can, JVM developers can essentially say, like, try this out. Brian Getz said, like, give us feedback. And it's fun. The two things to remember. Yeah, like you said, first of all, this is it's an experimental feature. So you can change, even though I think the way it is only if it's something like really, really broken. They don't tend to change too much, was the previews. But the other one is that 14 is also not considered a long-term release. So
that's right.
If you happen to say, like, oh, I'm going to use 14 for records and stuff like that, just be cognizant that there might be an upgrade for you for 15 when 14 becomes end of life, right? So
yep. Yeah, no, those are important to note. And speaking of Brian Getz, he also has an article out there on InfoQ that we reviewed before this episode, going through some of these details. What are records? And there you're getting it. I mean, to quote straight from the horse's mouth.
He implemented it, right?
What they have in there. So I mean, there are some things that you can do within the actual record class. For example. He's got it here where
validation
do some validation. If you want to do some validation on the objects after they're passed in. So this has the look of a regular constructor where it's actually taking it and performing some executable code.
So the way it's defined on this example would be like a public record. I think he did a range, right, and then open parentheses, int low, comma, int high, close parentheses, that's the record signature, but then the curly bracket, and then you define what you consider the regular constructor that you expect the record to generate, which is, public range, open parentheses, int low, comma, int high, close parentheses. And it's almost like you're repeating the same thing over again inside. And then when you open the curly brackets, then you can do if low more than high, throw illegal argument exception. So that there's this way you can essentially prevent from bad records to be created. And it's interesting because that I had to revisit a similar example today. We were having a discussion of something that Martin Fowler is very against, which is this concept of what he calls anemic classes. And anemic classes are essentially classes that are strictly only data structs. Like they don't know if their data is valid. They don't know if their data makes sense. And Martin Fowler was always on the camp of, look, you are essentially paying the penalty of creating an object-oriented programming sort of like structure. Might as well take advantage where is data and behavior go to the same place. That's the whole thing, So when you create a class, make sure that your object is not just a vessel for things. Make sure that there is some business logic, for example, to understand does the class parameters are making sense. So it's interesting that for records you do have the ability to add a little bit of that sort of like business behavior, saying like, oh, you're creating a incorrect record, so let's just throw an illegal argument exception before, and it's not preventing you from essentially shooting yourself in the foot later. So
exactly. Yep. So I mean those are all things that records help you kind of enable, so they have that ability still to put business logic in, if that's what you, if you want to, or if you don't, you have that option. So, so let's see if there's anything else interesting here that we can go after. So that I'm gonna do the thing that every junior Java developer probably does, just to see if it works, right? So we already did the equals. What if I do print line, the awesome? So that's our awesome object, equals.
Oh my gosh.
Another awesome.
Reference equality?
So this is I'm testing, right. So I'm testing now for reference equality. What do we think is going to happen here? Is this going to be the same as a class or a different?
Oh my gosh. Well, so I am curious. I don't know.
Yeah. So it's false.
Okay.
So in this case, it's exactly like a Java class. Now, this is where I say this is a step towards value types. If you're a value type, this should be true, right? If you're a struct,
reference,
this should be a true statement. But since they are actually objects under the covers, the reference equality is not there.
I see.
These are still two distinct objects, and if you were to hook a debugger up to this, you would see two objects on your heap. So these aren't being inlined or anything like that. Behind the scenes, these are still objects referenced on your heap. They have, different hashes, if you were going to look at that. So, with that knowledge, what would happen if I were to say take a list of awesome? So I can curate lists. So this is the awesome list equals new array list. And if I were to put, so the awesome list, I got a capitalization, and add the awesome, and the awesome list, add another awesome. How many objects do you think would be in this list?
So this is a list. There should be two of them.
So if we do that.
So we're going to system out print line, the awesome list.
The awesome list, and then we'll do size.
Yeah.
Now, knowing what we know about the reference equality, this should be obvious, right? So if they're both distinct objects and I added them to a list, I should get two.
Yep.
And I do. So that makes sense. But what if instead of a list, I change this to a set?
Now, sets usually will go with the implementation of equals. So yes, on that particular case, we should only have one.
And we do. So again, you're starting to see kind of, even though it's like, okay, yeah, so you gave me equals for free, you gave me, toString for free. It's actually really powerful when you have both of those things. When you start talking about how you use this with your data structures, when you start talking about, hey, I'm going to be iterating through these in a stream and all these records, I want to know how many are unique. If I use a set, I don't have to think about the equality as long as everything in that set is a record.
Yep.
It's all there for me. And if it's records all the way down, if I put something in that set, I'm getting my equality and I'm not going to have any dupes. Guaranteed.
Yeah, no, I mean, it's interesting because it is doing the job of or like, again, Lombok was the poor man's replacements for those who don't have 14 records previous, right? And Lombok was it was interesting because it could not prevent you from doing things that in the way that records prevent, like, Lombok will still allow you to create a class however you want it and allow you to, for example, extend it. So you have inheritance on that. And then when Lombok was trying to generate code for that, it's not that it struggles, but you have to give it way more hints. Because it's like, well, I don't know if you want this to be final. I don't know if you want this to be immutable. I don't know if so do you want a default value? Do you want your builder to be done this way? This particular case, you are saying, yeah, you can inherit it. Your class is final, but these are the only things that it has, and that allows it to be very succinct on giving you the getters for it. And I think it's kind of interesting how they decided to avoid, because one of the problems, for example, not problems, but but like there are conventions, right? Like Lombok will have the get lists, or like, and there's singular and plural. Right. Plural sort of like treatments to that. Like Records is like, nope, I'm just gonna give you the name that you gave it to me, and that's all. We're not gonna play with singulars or plurals or anything like that. So it's a nice way to really remove the verbosity and make it much more succinct. Plus, it's easier to reason about. Like, when you see a record, you know what you're getting. You're getting something that is immutable. You know that it's, that you can just safely publish if you want to, that you can equals and hash code it, and it's going to work the way you think it's going to work. Like all of that, Lombok does not guarantee you that, because like Lombok, you just get a class, and if you're not familiar with Lombok, it could be anything. Like so, right. So yeah, this makes it, having it like being a first class citizen on the Java ecosystem, even though like behind the scenes it's doing the same. Not quite the same. I mean, the advantage is that Records, it is a new sort of like class type, and it has a new syntax and a new definition, which is something Lombok cannot ever do because they cannot change the language. Right. It's awesome. So.
Yeah, no, there's a lot you can do with it. And I mean, they're setting it up. They're coming into the preview with sort of an implementation that I feel they're going to be able to optimize. Yeah. They're coming in, they're just using what's there to start with, get it out the door, see how people use it. And then, on later releases, there's probably going to be things they can do that are just going to make this better, that, could make things fly. Yeah, which is kind of exciting.
Yeah, no, it's fun because the way it feels it was implemented. Yeah, it was implemented first to do not surprise anyone. This is really what you think. And it behaves the way you think it will behave. So that's fun. Well, I guess that's all we have in the agenda for Records, isn't it?
Yeah, I think we've covered pretty much all the things that I would want to cover, or at least I would want to know. I mean, so the main thing is, if you're trying to play with this at home, do follow the steps to enable the preview. It may be as soon as Java 15 when some of this stuff starts getting, actually, we should look at that. Let's see. If we look at Java 15, let's go there. So this is the article from Brian Getz. Java 15. Is it going to be hidden classes? No. So we don't have it on the Java 15 release. So it hasn't made the cut to get out of preview by then. But maybe Java 16, and you'll have these things available as a regular feature. Just depends on the usage. Mm-hmm.
I know that I think that one of the things that I'm looking at that I did not realize, Dr. Hines talked about that serialization of records is a little bit different.
Okay, yeah. Why don't we talk about that real quick?
So if you ever use Java serialization mechanisms, I'm sorry. All right, even Brian gets it. He recognizes that I think he called it like a feature that's trying to be a framework or something on the lines of that, where he recognized that it was very hard to get right from the beginning. Like, and again, when it was done, it was done in the best ways possible. But now, after all of us using it for a long while, we got feedback. And I think one of the things that happened was that one of the things that serialization does is it creates a magic empty constructor. And essentially it's a way to circumvent object initialization and lifecycle, right? So I think that Records, they try to implement it in such a way that when you are serializing it, that you don't go through the shenanigans of you need to declare an empty constructor, and they relax some of the UUID's requirements for records to be equal, right? Or for serialization to happen. So there are a couple of differences. I think, and Dr. Hines does cover in. But I'll say, like, if you're still using like Java serialization, like if you never use it, it's not a good time to start. If you are using it and can survive, then just be aware that there is differences on serializing records. Like I think one of the things, for example, records by default always have a zero version UID of 0. Like so things you'll be able to essentially evolve the records or devolve the records, or deserialize incorrectly. So things to watch out for. We'll put it on the show notes as well. So I think that's it. So this was our first try on doing a Java Pop House with screen share. So we'll create all the different channels and make sure that it's both on the website. We'll create a YouTube channel. We are finally welcome to 2005. We're slowly making our way. And then I'm sure that for the next one, we'll try to see if you can see Bob's and my face when we're discussing these things. It will be kind of fun.
I mean, that means we'd have to dress up and wear pants. I
know. Well, I don't know.
Well, maybe not pants.
Shirts. No.
Yeah.
And it's like I need a haircut, and I do need to shave.
I'm in the same boat. At some point, all this craziness will be behind us. But we're moving forward. We got the screen share going. Give us feedback. Hit us up on Twitter if there's things you want to see that you weren't seeing, or things that we can do better with it. But go forth and use records. Give feedback. I'm sure that the OpenJDK team they're putting out these previews so that they can get the feedback, so they can get the features right when they do go into the main line as regular features. So use the opportunity. And let them know what you think. Yeah. And if you're just tuning in and discovering the podcast, there's two things I'm going to ask you. First of all, Java Pop House is one of the different podcasts that we have in the Pop House network. So if you go to pophouse.net, you'll find all the different properties that we have, including Java of Heap, which is our essentially pundits podcast, and it lets you, that one allows you to figure out what's going on with the Java ecosystem and what are the interesting parts that are moving on. Also breaking into open source, which is Bob and Josh run. So yeah, I need to. You need to go to pophouse.net now that pophouse.net should have all of them. See. Ooh.
No. Without the Java. Sorry.
Pophouse.net.
Yeah.
Yep, I got it.
So see.
There we go. Yep. Here we go.
Yeah. So breaking into open source is Bob and Josh podcast, where they go into like the different open source projects and how to contribute to them. And lastly, because we are old in quarantine now, that's when we also have the Stack podcast, which is run by Josh, Kito, Ian, and Danielle, where they go over essentially. Not just necessarily the backend where we concentrate on Java and Java JVM languages. They actually cover the full stack. So they talk about JavaScript frameworks and stuff like that. We say we don't hate them for that. We appreciate them, but it might not it's just not my cup of tea. If I can avoid doing JavaScript, it's not a bad day. So that's it. So please follow us and all that. Definitely follow us in Twitter at Java Pop House. That's our handle there. And check the other podcasts out. So Brave New World. I think that's all what we have for today, right?
I think so. I think that was a pretty solid episode. So
yeah, check it out, and I'm sure that there are more 14 things that we're probably gonna be hitting now that is released. And with that, I think that's all what we have. Happy programming, everyone.
Take care.
Bye-bye.